today we're taking a look at a globular cluster called Messier 72. And, at first glance, it just looks like a pretty simple, ancient ball of stars. But if you dig a little deeper, you find this incredible story of a cosmic pulse, a really violent past, and a beautiful, elegant dance with our own galaxy. So here's how we're going to break it down. First, we'll get to know the cluster itself. Then, we're going to uncover its secret stellar heartbeat. We'll use that to figure out its unique identity, see the evidence of its rough and tumble journey, and finally, reveal the incredible orbital path it traces through the Milky Way. All right, let's start with the basics. Our subject today is Messier 72, or M72 for short. It's what astronomers call a globular cluster, which is basically a jam-packed spherical city of hundreds of thousands of really, really old stars. Now, M72 is often described as a loose scattering of stars, especially when you compare it to some of its more famous, super dense cousins. But don't let that word loose fool you. We are still talking about a massive city of stars. And it's a city that is very, very far away. It's over in the constellation Aquarius, more than 54,000 light years from us. To put that into perspective, the light we're seeing from it tonight actually left those stars back when humans were living in the Stone Age. Just think about that. So you might be thinking, okay, it's old and far away, but does anything actually happen there? Is it just a static relic from the early universe? Well, it turns out that if you look close enough, these stars are not quiet at all. And that brings us to the cluster's hidden pulse. See, the real key to understanding M72's story isn't in the stars that are constant, but in the ones that actually change over time. And these are the stars we're talking about, RR Lyrae variables. You can think of them as the cluster's cosmic metronomes. They're old stars, and they are literally pulsating, getting brighter, then dimmer, with a super precise rhythm. And that rhythm holds some vital clues. For a long time, we thought we had a pretty good count of these stellar metronomes in M72. But a recent study took a much closer look, and what do you know? They found 3 previously unknown variable stars, finally giving us a complete census. And these weren't just random finds. They were able to identify their specific types. 2 of them are AB type, which means they pulse in their main fundamental mode. The other one is a C type, which pulses in a faster first overtone mode. Knowing their exact type and their timing is absolutely crucial, because that's how we can unlock the cluster's true identity. So, how does a stellar pulse work like a fingerprint? Well, it allows astronomers to classify the entire cluster and figure out exactly where it fits in the grand scheme of the cosmos. This all goes back decades to a Dutch astronomer named Pieter Oosterhoff. He made this amazing discovery. He realized that globular clusters with these RR Lyrae stars don't just have random properties. They fall very neatly into one of 2 distinct groups. He found 2 main categories. You've got type 1 clusters, where the main pulsating stars have a shorter average period, around half a day. And then you have type 2, where they have a longer average period, closer to 2/3 of a day. It's this really clear split. There's almost nothing in between. You're either one or the other. And here's the payoff. By carefully measuring the pulse of all its variable stars, including those 3 new ones, astronomers calculated the average period for M72. It came out to 0.563 days. And that confirms with brand new precision that M72 is a classic Oosterhoff type I cluster. We've officially identified its fingerprint. But that fingerprint is only one piece of the puzzle. If we zoom out from the cluster's core, we start to see signs that M72's long life has been anything but peaceful. It's actually been under attack. For years, astronomers had these strange hints. They kept finding stars that definitely belonged to M72, but they were way outside the cluster's gravitational grip, what's called its tidal radius. It was a real mystery. Why were these stars escaping into the void? And this is the smoking gun. This incredible map shows what happens when you digitally remove all the other stars in the foreground and background. What's left is the undeniable shape of M72 being actively torn apart, with streams of its stars being pulled away into space. There's a name for this process: tidal disruption. Basically, as M72 orbits our galaxy, the massive gravitational pull from the Milky Way tugs harder on the side of the cluster closer to us than it does on the far side. And that difference in force literally stretches the cluster out, slowly stripping stars away into these long trailing tails. All of this leads us to the final and maybe most stunning part of the story. The fact that the cluster is being torn apart actually tells us something profound about its journey through our galaxy. So you have to wonder, right, with this constant gravitational assault happening, what kind of orbit is this thing even on? Is it just on some chaotic path, slowly getting destroyed? Or is there something more elegant going on? Well, to figure that out, scientists ran these powerful computer simulations to trace M72's path through space. And hidden in all that data, they found something both precise and beautiful. They found, as this quote says, a clear 3-to-2 resonance, which creates an orbital pattern that kind of looks like a fish. What this means is that M72's orbit isn't random at all. It's actually locked in a stable, repeating gravitational dance with the Milky Way. It's a phenomenon called an orbital resonance, a state of perfect gravitational harmony. So what on Earth is a 3-to-2 orbital resonance? Well, it's a stable pattern where for every 3 times M72 completes its long, swooping orbit through the galaxy, the inner parts of the galaxy itself complete 2 orbits. They're locked in this rhythm. And this pattern perfectly explains why it's getting torn apart, because its orbit regularly brings it in close to the galactic center, where those destructive tidal forces are the strongest. And so what started as just a loose scattering of stars becomes this incredible character in our galaxy's story. It's an ancient survivor whose pulse tells us its identity, and whose path reveals this graceful, yet violent dance of disruption and resonance. It really makes you wonder, doesn't it? How many other incredible stories like this, written in the motion of stars, are still out there just waiting for us to read them?